So in the last class, we were discussing about multiplication of vectors. So as I mentioned that there are two types of multiplication of vectors. One is dot or scalar product. Other one is cross or vector product. So in dot product, after multiplication of two vectors, we will always get a constant or a scalar, hence it is called as scalar product. In cross product or vector product, after multiplication of two vectors, we will get another vector, hence it will be called as vector product. So dot product definition I was mentioned in the last class. That is, suppose A and B are two vectors. According to the definition of dot product. So it is A dot B. A dot B is equal to magnitude of A, magnitude of B into cos theta. So what is theta? Theta is angle between the vectors. Angle between the vectors. That is, suppose this is vector A and this is vector B. In between these two vectors, we have an angle theta. So this will be the definition of A dot B. Finally, you will always get some constant. This is the definition of dot product or scalar product. And we have also discussed the properties of dot product. Properties of dot product. In that topic, I proved that I dot I is equal to j dot j is equal to k dot k is always equal to 1, and also proved that I dot j is equal to j dot k is equal to k dot I is always 0. And we have derived the dot product formula, that is A1 B1 plus A2 B2 plus A3 B3. So till this we were discussed in the last class about the dot product. So I will repeat it. Dot product definition is A dot B is equal to magnitude A, magnitude B into cos theta. Theta will be the angle between the two vectors. And we were also discussed these properties. If I take two unit vectors along the same axis, x-axis, their dot product is always equal to 1. That is, I dot I is equal to j dot j is equal to k dot k is always 1. So if I take the unit vectors across the perpendicular axis, if I take I dot j, j dot k, k dot I, you are always getting the 0. I dot j is equal to j dot k is equal to k dot I is always 0. Suppose A and B are two vectors. A is equal to what? A is equal to, so A1i plus A2j plus A3k, and B is equal to B1i plus B2j plus B3k. Product of these two will be always obtained as A1 B1 plus A2 B2 plus A3 B3. So this formula was derived in the last class. Let us check what are the other properties of dot product. The other properties are, we can find cosine of angle between the vectors. Cosine of angle between the vectors. Cosine means cos of an angle of the vectors. Suppose you take the definition of A dot B. What is A dot B? A dot B is equal to magnitude of A, magnitude of B into cos theta, right? This is the definition of dot product. With this I can derive or I can get the cos of angle. The cos of angle is what? Cos theta is equal to these magnitudes will go to the denominator of left hand side, correct? Therefore I can write it as cos theta is equal to A dot B divided by magnitude of A, magnitude of B. This is the cosine of angle between the two vectors. So with this same formula, I can get the angle between the vectors. Next one is angle between the vectors. With the same formula, I can get the angle between vectors. So what is cos theta? Cos theta is equal to A dot B divided by magnitude of A, magnitude of B. So as we know that cos theta is equal to A dot B divided by magnitude A, magnitude B. With this, I can write the angle. What is angle? Theta. Theta will be equal to cos inverse of A dot B divided by magnitude A, magnitude B. In this way, we can get the angle between the two vectors. So next property, orthogonal vectors. Orthogonal or perpendicular. Orthogonal or perpendicular vectors. So two vectors are said to be orthogonal or perpendicular. So when two vectors are perpendicular, what will be the angle? So angle will be always 90 degrees. Correct? See, A dot J, sorry, I dot J, A dot K, A dot I, they are what? They are the perpendicular vectors along the x-axis, y-axis and z-axis. If I take any two perpendicular axes, unit vectors ij, their product is always getting 0. It means that when two vectors are said to be orthogonal or perpendicular, their dot product is always be 0. So I can write like this: if A dot B is equal to 0, then A and B are orthogonal vectors. Orthogonal or perpendicular vectors. Next property, we can project one vector on another vector. That is projection of vector A on vector B. So what is meaning of projection? Let us take two vectors. So this is vector B. This is vector B. Somewhere here we have a vector A. I can project this vector A on vector B. How it will be projected? See. So B on B, A is projected. So this will be called as projection of A on B. We can get this using dot product. Projection of A on B is always equal to their dot product divided by on which vector projected. We are projecting A on B, whose magnitude is to be taken. That is A dot B divided by magnitude of B gives you projection of A on B. So we can also project projection of B on A. We can have a projection of angle B on projection of B on A. So that formula is same thing, A dot B divided by magnitude of A. So I should take B dot A. So B dot A and A dot B one and the same. Therefore, I have taken it as A dot B divided by magnitude of A. This is the formula to get projection of one vector on another vector. Right? These are some of the properties of dot product. One is cosine of angle. It is what? A dot B divided by magnitude A, magnitude B. Angle between the vectors, it is A dot B. Cos theta is A dot B by magnitude A, magnitude B. With that, I can write theta is equal to, that is theta is what? Angle between the vectors. Cos inverse of A dot B by magnitude A, magnitude B. Orthogonal vectors are perpendicular vectors. Suppose if I take vector A and B, if their dot product is 0, then we can say that these two vectors are always perpendicular or orthogonal. And projection of one vector on another. Suppose if I want to project A on B, what is formula? That is A dot B by magnitude B. Projection of B on A, same formula, but on which vector we are going to project it. So whose magnitude will be taken at the denominator, right? Apart from this, there is an application of dot product. We have an application of dot product. That is work done by a force. As we know that work is done by a force when the object is moved from one point to the another point. Otherwise, the product of mass and displacement will give you the work, right? So work is equal to force into distance or displacement. See this. This is an object which is placed at A, right? The object is subjected to a force. The object is subjected to a force. By the application of this force, the body moves to another position. It is B. Earlier it was at A. After application of the force F, it moved to the point B. Now we have a distance moved by the body is AB. What is distance moved by the body? It is A to B. I will call it as vector S because it is moving in a particular direction. Right. So what is S? S is equal to vector between 2 points. So vector is represented here with the help of position vectors. So AB. Vector S is equal to what? AB. AB is always OB, position vector of terminal point minus position vector of initial point. So according to this, we get S. With this S and force, I can get the work. So work is equal to F dot S. F dot S. So what is A? Here A is force acting point. It is important. Force acting point. Force acting point. B is always be considered the point which is move point. Body moved point will be taken as B. Then you will get S is equal to AB. This is an application of dot product. Let us work out problems on each property and also on application, right? Problems. So all the properties which involve the dot product and the magnitude of A or B. So it's very simple. If you remember the formulas or the properties, it's easy to work out any problem. If A is equal to 3i minus 2j plus 5k and 4i plus 3j plus 2k, find A dot B. Sometimes it will be mentioned as find dot or scalar product. Dot product or scalar product. So as we know that, suppose if A is equal to A1i plus B1j plus C1k, B is equal to B1i plus A is A1i plus A2j plus A3k, and B is B1i plus B2j plus B3k. Then A dot B is equal to what? It is I1 A1 B1 plus A2 B2 plus A3 B3. So according to this, for the given vectors, dot product is what? What is A1? A1 is 3. This is taken as A1, this is taken as A2, this is B3. This is what? B1, this is B2, this is B3. So A1 is 3, B1 is 4, 3 into 4, put a bracket, plus take B A2, A2 is what? Minus 2 into B2 is what? 3, plus A3, A3 is what? 5, B3 is what? 2. This is the simple way of getting A dot B. 4 into 3, 12. Take the minus into consideration here. Plus into minus, minus. 2 3s are 6. Plus 5 2s are 10. 12 plus 10 is equal to 22. 22 minus 6. That is equal to 16. So 16 is the dot product of the given vectors, right? Next problem, if A is equal to I minus 3j plus 4k and B is equal to 5i minus 3k, find 3a dot 2b. Find 3a dot 2b. So 3 is constant, which is to be multiplied with vector A. Then B is multiplied with the vector B. The resultant vector should be taken for dot product. First get 3a. What is 3a? 3a is equal to 3 into I minus 3j plus 4k, which is equal to 3 into I, 3i minus 3 3s are 9j plus 3 into 4, 12k. Next, let us calculate 2b. 2 into b. 2 into what is b? It is 5i minus 3k, which is equal to 5 2s are 10i plus into minus minus 3 2s are 6k. We don't have j terms, right? Then we have to put 0 into j. Now 3a dot 2b. 3a dot 2b is equal to, write 3a, that is 3i minus 9j plus 12k dot 2b. 2b is what? 10i minus 6k. Take the product, 3 into 10. 3 into 10. Okay. Plus minus 9. So j coefficient is what? Minus 10. Here we don't have j term, right? Therefore we have to take 0. 0 into j. Plus 12 into minus 6. Correct? That is equal to 3 into 10. It is 30 plus or minus 0. Plus into minus is minus. 12 into 6. 72. That is equal to 42 minus is the dot product of 3a and 2b. Let us work out problems on getting cosine of angle and angle between the vectors. Okay. Find cosine of angle between the vectors 2i minus 3k and 5i plus 2j minus k. You can consider any vector between that, whatever the cosine of angle will be there, that can be calculated. Let the given vectors are taken as a, b. What is a? A is 2i minus j plus 3k. And b, what is b? B is 5i plus 2j minus k. What they have asked? They want to know cosine of angle between the vectors. Write the formula. Cosine of angle. Cosine of angle is what? Cos theta is equal to a dot b divided by magnitude a into magnitude b. To substitute in this formula, we need a dot b and magnitude a, magnitude b, right? First get a dot b. A dot b. What is a? Take the vector a, 2i minus j plus 3k into what is b? 5i plus 2j minus k, which is equal to 2i into 5i, that is 2 into 5 plus of j coefficient is what? Minus 1 into 2 plus 3 into minus 1. 2 5s are 10. Plus into minus minus 1 into 2 2 plus into minus minus 3 into 1 3. It is 10 minus 2 minus 3 is what? Minus 5. Therefore, we are getting a dot b is equal to 5. 10 minus 5 is 5. Then calculate magnitude of a. So magnitude of a is equal to what? It is the square of constants 2 minus 1 3 and then add. Okay. 2 square it is 4 plus minus 1 square is 1 plus 3 square is 9, which is equal to root 14. Magnitude of b, that is equal to root of, which is b. B is 5i plus 2j minus k. Square this, square all the numbers and add them, right? 5 square 25 plus 2 square is 4 plus 1 square is 1. That is equal to root of 30. So we got a dot b, magnitude a, magnitude b. Just to substitute all the values in the formula. Therefore, cos theta is equal to a dot b divided by magnitude a, magnitude b. What is a dot b? It is 5. Magnitude of a dot b is 5. Sorry, dot product of a and b. What is magnitude of a? It is root of 14 into root 30. Otherwise, you can simplify these two. Root 14 into root 30. It can be taken as 30 into 14. 3 4s are 12. Carries 1. 3 into 1 3. 3 plus 1 4. It is 420. It is root of 420. This is the cosine of angle between the vectors a and b. Next one, find the angle Find the angle between the vectors I plus 2j minus k and 2i plus j plus k. Consider the vectors, given vectors as a and b. A is I plus 2j minus k. B is equal to 2i plus j plus k. So we need to calculate angle between the vectors. So according to the cosine of angle cos theta is equal to what? Magnitude of, sorry, a dot b divided by magnitude a magnitude b. With that I can reduce for theta. Angle between vectors. Angle between vectors, that is theta is equal to, it is cos inverse of a dot b divided by magnitude a magnitude b. Similar to the previous problem, you get magnitude a dot b as well as magnitude a magnitude b. First find out magnitude of a dot b. What is a? It is I plus 2j minus k into, what is b? B is 2i plus j plus k, which is equal to 1 into 2 plus of 2 into 1 plus of minus 1 into 1. This is equal to 2 into 1, 2 plus 2 minus 1. 2 plus 2, 4. 4 minus 1 is 3. A dot b is equal to 3. Magnitude of a, it is equal to magnitude of a. This is the vector a. 1 square 1 plus 2 square 4 plus 1 square is 1. It is equal to root 6. Magnitude of b, which is b. B is equal to 2i plus j plus k, right? Root of 4 plus 1 plus 1, which is equal to root 6. So we got magnitude a and magnitude b equal. Therefore theta is equal to what? Cos inverse of a dot b divided by magnitude a magnitude b. Just substitute the values. Cos inverse of a dot b is how much? It is 3 divided by, what is magnitude of a? Root 6. What is magnitude of b? Root 6. Or cos inverse of 3 divided by root 6 into root 6. It is 6. Or 3 1 the 3 2 the. Theta is equal to cos inverse of 1 by 2. For what value of cos you will be getting off, as we know that for cos 0 is equal to 1, cos 30 is equal to 1 by, sorry, root 3 divided by 2. Cos 45 is what? It is 1 by root 2. Cos 60 is what? Cos 60 is equal to 1 by 2. Right? So then 60 degree can be taken as cos inverse of 1 by 2. In the place of cos inverse of 1 by 2, I can take as 60 degree. So angle between the two vectors is equal to 60 degree, or it is also in radian. If I want to write it in radian, it is pi divided by 3 radian. Next problem on orthogonal vectors. Show that the vectors 3i plus 2j minus k and I plus j plus 5k are orthogonal. Orthogonal vectors are perpendicular vectors. So when the two vectors become perpendicular, If and only if their dot product is equal to 0. Let us see the dot product of the given vectors. Let take the given vectors as A and B. A is 3i plus 2j minus k, and B is equal to I plus j plus 5k. Take the dot product. A dot B is equal to 3i plus 2j minus k, which is A, dot B is I plus j plus 5k. That is equal to 3 into 1 plus j coefficient is what? 2 plus 2 into here is 1 plus k coefficient minus 1 into k coefficient 5. That is 3 plus 2 into 1 is 2 plus into minus 1 into 5 is 5. 2 plus 3, 5 minus 5, which is equal to 0. So dot product of the given vectors is what? 0. Hence we can say that the vectors are perpendicular. A dot B is equal to 0. Hence the vectors are perpendicular or orthogonal. The vectors are said to be orthogonal or perpendicular, provided their dot product is always 0. Sometime a cross question will be asked based on this perpendicular vectors. Say, find the value of lambda if the vectors 3i minus 7j plus 2k and 4i minus 3 are lambda j plus 3k are orthogonal or perpendicular. There are two vectors which are perpendicular, right? Vector B, which are orthogonal or perpendicular. So in these two vectors, one unknown is there. So it is unknown lambda, whose value is to be found. Okay. The value of lambda should be obtained based on the condition of orthogonal vectors, right? Let A is equal to 3i minus 7j plus 2k, and second vector is considered as B. B is 4i minus lambda j plus 3k, which are perpendicular vectors. It is mentioned in the problem itself. Therefore, as we know the condition for perpendicular vectors, their dot product is always 0. Using this condition, you can get A dot B, that is 3i minus 7j plus 2k into what is B? B is 4i minus lambda j plus 3k is equal to what? We should take their dot product as 0. 3 into 4 plus j coefficient is what? Minus 7 into j coefficient is minus lambda plus 2 into 3 is equal to 0. 4 3s are 12. Minus 7 into minus lambda, minus into minus plus, plus into plus is plus, 7 into lambda is 7 lambda, plus 2 into 3, it is 6, is equal to 0. 12 plus 6 is 18. 18 plus 7 lambda is equal to 0. With this, you can get lambda. So 7 lambda is equal to what? Minus 18. Hence, lambda is what? It is minus 18 divided by 7. By considering this lambda value in the given vectors, if you do the dot product, definitely you will get 0. So this is the way in which we can get the unknown values if they mention that the vectors are orthogonal or perpendicular. So next question, find the projection, find the projection of 3i plus 2j minus 5k on 2i plus j plus k. Here it is not mentioned which is A, which is B. You just take them, the first vector as A, second vector as B. If you consider like that, then you need to calculate what? Projection of A on B, right? Let us take the first vector is A. Let A is equal to 3i plus 2j minus 5k, and B is equal to 2i plus j plus k. So we need to calculate projection of first vector on second, means A on B. What is formula for that? First write the formula. Projection of A on B. Projection of A on B is equal to A dot B divided by magnitude of B. If they give specifically vector A and B, then you can take according to that. But here it is not mentioned which is A, which is B. We are taking the first vector as A and second vector as B. Therefore, we are getting projection of A on B. To substitute in that formula, we need A dot B and magnitude of B. A dot B is what? 3i plus 2j minus 5k into B is 2i plus j plus k. That is equal to 3 into 2. 3 into 2, right? Plus j coefficients 2 and 1. 2 into 1 plus k coefficient minus 5 into 1. That is 3 2s are 6 plus 2 into 1 2 plus into minus 5. So 6 plus 2 8 minus 5, which is equal to 3. I got A dot B as 3. Then I need magnitude of B. Get the magnitude of B. It is equal to, which is B. This is B, right? Magnitude of this is what? 2 square is 4 plus coefficient of j is 1. 1 square is 1 plus coefficient of j is 1. 1 square is 1. Hence it is what? 6. Therefore, projection of A on B is, what is the formula? You can rewrite, otherwise directly write the values. So A dot B is 3 divided by root 6. Next problem. If A is equal to I minus 5j plus 2k and B is equal to 3i plus j plus 2k, find projection of B on A. Projection of B on A. So we need to repeat the same procedure of previous problem. Here we need to find out by projection of B on A. They have mentioned that A is I minus 5j plus 2k and B 3i plus j plus 2k. Directly you get A dot B. What is A dot B? 1 into 3, you can write directly 3 minus 5 into 1, that is minus 5 plus 2 into plus 2, it is plus 4. 3 plus 4. Positive number is 7. Negative number is minus 5. Take the difference, which is equal to 2. We need to find out projection of B on A. So then we need magnitude of A, right? Magnitude of A is root of A I minus 5j plus 2k. So 1 square is 1 minus 5 square. It is 25 plus 2 square. It is 4. Root 30. Therefore, projection of B on A is equal to A dot B divided by magnitude of A. What is A dot B? It is 2 divided by magnitude of A is what? It is root 30. This is the projection of vector B on A. So next problem is on application, that is work done. A force 3I plus 2j plus k is acting on a body at the point 3 comma minus 2 comma 5 and displaces to 1 comma 3 comma 2. Find work done by the force. This is the problem. A force is acting on a body at some point and it will be moved to the another point. This is another point, moved point. So with that data we need to calculate work done by a force. So as I mentioned earlier, when a body is subjected to a force F at a point A and it is moved to the another point, that is point B. This is moved point, right? Moved point. Which is moved point in the problem? So the point followed by 2. The point followed by 2 will be the 2 point, right? 2 from or at. So at or from, that word indicates initial point or the force acting point. Moved to. So 2 point always moved point. It is 1 comma 3 comma 2. Force acting point is what? Force acting point. Force acting point. Acting point is 3 comma minus 2 comma 5. So write the position vector of the points. It is A. Therefore, force acting point is A. A is what? A is having the coordinates 3 comma minus 2 comma 5. Therefore, its position vector is equal to, position vector is OA. OA is equal to 3 comma minus 2 comma 5. Or I will write it in IJK. 3I minus 2j plus 5k. Plus 5k. Body moved point. Body moved point is what? B. So which is B? 1 comma 3 comma 2. Therefore, its position vector is what? Position vector of moved point, that is B, OB, is equal to, just include IJK, 1I plus 3j plus 2k. With this, get the distance moved by the body. S is equal to AB. AB. AB is what? Position vector of end point, terminal point OB, minus position vector of first point, that is OA, is equal to, write OB. OB is I plus 3j plus 2k minus of OA 3i minus 2j plus 5k. Simplify it. Remove the bracket. I plus 3j plus 2k minus of next vector. That means we should multiply all the terms with minus. Minus of 3i minus into minus plus 2j minus into plus minus 5k. All the terms of subtrahend whose sign will change. Minus become plus, plus become minus. That is equal to I minus 3i is what? Minus 2i plus 3j plus 2j, it is plus 5j plus 2k minus 5k. We should take the difference, that is 3k. This is yes. F is given. What is force? Force is equal to what? Force, a force of 3i plus 2j plus k. Now what is work done formula? Work is equal to F dot S. F dot S. Write F first, that is 3i plus 2j plus k into or dot yes. What is yes? Minus 2i plus 5j minus 3k. Get the dot product. So 3 into minus 2, it is minus 6 plus 2 into plus 5, that is equal to plus 10 plus 1 into minus 3, it is minus 3. So minus 6 minus 3 is minus 9 plus 10, which is equal to what? 1. So work done by force is equal to 1 unit. You just mention answers. Answer in a unit. 1 unit. Right? Sometime a body is subjected by more than one force. More number of forces are acting on a body. See, if the forces I minus j, comma 2i plus 3j and 4i plus 2j are acting on a body at 1, 3 and shifted to the point 4, 1. Find the work done. Find the work done by the forces. Work done by the forces. So here there are 3 forces are acting on a body. The first force, second force, third force. So when more number of forces are acting on a body, then we should take their net force or combined force. Take the first force as F1, I minus j. Second force as F2. F2 is equal to 2i plus 3j. And third force is equal to 4i plus 2j. How to get net force? Just adding all the forces. You will have a net force or combined force. Therefore, F is equal to F1 plus F2 plus F3. F1 plus F2 plus F3. That is I minus j plus 2i plus 3j plus 4i plus 2j. Add them. All I terms are added. 1i plus 2i, 3i plus 4i. It is 7i. Add the j term. Minus j plus 3j, it is plus 2j, plus 2j plus 2j, it is plus 4j. This is the net force, right? Then there are 2 points. One is force acting point, other one is body move point. Take them as OA, OB. Force acting point, that is A, which is A. A body is force acting on a body at, so at will become acting point 1 comma 3. Therefore their position vector is what? OA. OA is equal to I plus 3j. Then body moved point, which is that B. So what is B? Shifted to end point is 4 comma 1. Therefore OB is equal to 4I plus j. We have a position vectors of force acting point and body moved point. Then S is equal to what? AB, right? So AB is what? OB minus OA, that is equal to, right, OB 4I plus j minus of, right, OA I plus 3j. Remove the bracket, that is 4I plus j minus I minus 3j, which is equal to 4I minus I, it is 3I plus j minus 3j, it is minus 2j. That is the displacement. Okay. Then work done is equal to F dot S. What is F? F is equal to 7I plus 4j into, what is S? S is equal to 3I minus 2j. That is 7I into 3I. 7 into 3 plus of 4 into minus 2. 7 3s are 21 plus into minus, minus 4 2s are 8. So finally you will get 13 units. 13 units. That is the total work done by the forces. So this is the procedure to get work done by the, if more number of forces are acting on a body, then you first take all their net force by adding all the complementary forces. As usually, take the force acting point, body moved point, calculate S, then substitute in the work done. So these are some of the problems based on the dot product, right? So in this class we learned what is dot product, what are all the properties of dot product, and what is the application of dot product, and we worked out problems on each properties. We have worked out one problems. To become perfect, please work out more number of problems based on the properties. Definitely it is very important for your examination point of view, right? With this I conclude today's class. Thank you.